Okay, so these first two functions, these are your parent functions because we have we have a growth and a decay. So obviously 2 to the power of x is what? Growth or decay? Growth. 2 is larger than 1. How else do you need to read that?
1 parentheses 2 parentheses 2.
Okay. Make sure if it is just a number, you read it as 1 times so that you know what that a value is whenever you're graphing it. Okay, so obviously the 1/2, that would be decay. We've already talked about this a little bit. Domain is always going to be what? All real numbers. Do those two things mean the same right there? Yes. Taryn, what would my range be on this one? What to positive infinity?
1.
Does it go below 1?
Yeah.
So you're right to positive infinity. But from where to positive infinity? Zero. And that would be the same for your decay. Okay. Whoa. Why did I write it like that? Change those. If you're writing it like I was, change those. The inequalities there. I don't know why I wrote those as greater than. The horizontal asymptote. Kind of already hinted at it. Again, it's make sure that you're writing that as y equals. Okay, both of these are going to be at y equals 0. So just some basic characteristics of these graphs you're going to need to identify really on any graph that you're dealing with, especially that horizontal asymptote and identifying if it is growth or decay. So let's go through these hopefully pretty quickly. If the a value is negative, what's that going to do? Reflect over what? Reflect over the x-axis. If a is greater than 1, what is that going to do? No. Vertically stretch. Neve, if a is between 0 and 1, what's it going to do? Vertically compress. Abby, what 2 directions does the c value move it?
Right and left.
With or opposite the sign? Opposite the sign. Jeremy, the d value, which 2 directions is that going to go?
Up and down.
With or opposite?
With.
And we'll slow down and talk about this right here, because we put base on here because, you know, the base function, the regular function that we looked at last class was a times b to the power of x. Well, that b is the base. And every time we talk about transformations, you know, we've had that b value, the horizontal stretch or compress. So we just wanted to kind of separate those so that you know that there's a base and then there's that b value that can be up in the exponent, which the base, that is just your growth or decay factor, depending on whether or not it is greater than 1 or between 0 and 1. If your b value is greater than 1, that is going to do what? Horizontally compress. And so between 0 and 1, that is going to be a horizontal stretch. Remember, those are the ones that's always by the reciprocal, so whatever the number is in the equation is not going to be the number that you're going to put if you had to write the transformation down. One thing that you're going to have to do whenever you're looking at the equation, and probably the first thing I will do, and we'll look at this more on the back when we're graphing, the d value. You've got to identify your horizontal asymptote. Okay, it's pretty difficult. It's whatever that number is. Okay, that d, if it's plus 3, the very first thing I would graph on it is a horizontal line at y equals 3. If it's minus 7, y equals negative 7. If there's not one, what would it be? 0. It didn't move. Just like on the parent functions up top. Okay, so we're going to go through, let's go through these 4 real quick. We're going to identify if it's growth or decay, and then all the transformations that are on there. Alright, so Ben, on number 1, is that one growth or decay?
Growth.
Growth, why?
Because the base is bigger than 1.
Because 7 is bigger than 1. Okay. Cameron, what is a transformation that's going on there? Up 5. Miss Ray, what's another one?
It moves right, left,
How many?
2.
Dalton, what's the 3 up front do?
Horizontally stretched.
Vertically stretched. Okay, looking at number 2, Manny, is that growth or decay? Decay. Why? Because the base is 1/2. Isabel, what is one of the transformations? Okay. Kendall, what's another one?
Number 2.
Yes, ma'am.
Right, 7.
Anna, what's the last one?
Vertically compressed by 2.
It's the A value.
Vertically stretched by 2.
Yep. Guys, the B value is always going to be in the up the exponent. If you look at number 4, okay, we'll have a B value. Looking at 3, Peter, is that growth or decay? Growth. Cooper, what is one of the transformations on it? Okay. Sorry, I zoomed into the wrong one. Jeremy, what's another one?
Down 3.
Okay. Josh, what's another one?
Vertically stretched by 3.
No, there's no A value of 3 on there. What is the x plus 3?
Oh, right 3.
If it goes opposite the sign?
Oh, left 3.
Sorry, what's the last one?
I think
Did you say vertically compressed?
vertically stretched.
compressed. All right, going to, yes, Jesse. All right, going to 4. Hunter, is this one growth or decay?
Growth.
Is 2/3 greater than 1 or less than 1?
Okay.
Okay. Zach, what's the transformation on this one?
Compressed.
Nope.
Stretch.
Nope. There's no A value on there. The 2/3 is your base. So this is one that you'll need to see it as that right there. With the 1 up front. So what's the +1 at the very end doing? The D value is +1.
Oh,
Okay. Carolina, what's another one?
Left 2.
Starnes, what's the last one?
horizontal compressed
By?
by 1/2.
By 1/2. Okay, so on the B value, it's always going to be the reciprocal. So if it's horizontally compressed, it's horizontal compression because 2 is greater than 1, but the reciprocal of 2 is 1/2. So that's what how you would describe the transformation.
So what do you do with the 2/3?
That's the base that told you that it was decay.
Oh, okay.
Yep.
Do you do the reciprocal thing if it's horizontally stretched too?
Yes, ma'am. So if you had a horizontal stretch, let's say the 2/3 was the B value, you would say horizontally stretched by 3/2. Just flip it. Okay, so let's look at this. So looking at the first one, Zach, what is my horizontal asymptote? -3. So the first thing I'm going to do is I'm going to go to the graph, and I'm going to graph that right there. Eric, what is my domain? Hunter, what is my domain? What, Eric? All real numbers, always. Alright, so let's, looking at this, Jillian, what are the 2 transformations on this one?
Left 5,
And?
down 3.
Okay. Alright, whenever you're writing your range, just some rules on writing the range here. If you have a positive A value, okay, so that means it does not reflect, your range is going to be from the horizontal asymptote to infinity. If you have a negative A value, it is going to be from negative infinity up to your horizontal asymptote. So Jeremy, what would the range be on this one?
-3 to infinity.
-3 to infinity. Okay. To do this, so to graph it, because now that we have the horizontal asymptote, we gotta. Okay, well, Jillian said it moved left 5, so it's not going to be right there. Maybe it's just kind of to the left 5. So I'm just going to roughly graph it right there. That is not what I want. So if you just put that on your paper, and for whatever reason you're using a blue pen in my class, Manny Diaz, you're going to have to graph it accurately. A way that you can get points on this is always to put it into y equals and get some points, plot them, and graph it accurately. Okay? But to graph it by hand, you need to figure out what x value makes the exponent equal 0, 1, and 2. And then you'll make a little table and you'll have 3 points that'll show you roughly when that thing's going to start curving up, and it's going to be much more accurate than what Manny has on his paper. Okay, so looking at this, what is my exponent on this problem? Dalton, what is my exponent on this problem?
Your what?
My exponent.
X plus 5.
X plus 5. So what value of x would make my exponent 0?
Negative 5.
-5. Huh? The easy thing about this is once you find that one, it's pretty easy to figure out what's going to make it equal 1 and 2. Because you're just going to go up by ones. Okay? -4 plus 5 is going to give me +1. -3 plus 5 is going to give me 2. And then now I've got to find the y values. And that is a lot easier than it sounds. Okay, because these 0, 1, and 2 are easy exponents to deal with. Because if I plug in -5, this is now 0. And what does anything to the power of 0 equal? No. 1. So now this problem is 1 minus 3, which equals what? -2. So I know I'm going to have the point -5, -2.
Wait, Coach Howard.
Yes.
Can you repeat like what you just did? I'm so confused.
Okay. So I put -5 in for x. Okay, you with me? This is going to equal 0, right?
Yeah.
Okay. Anything to the power of 0 equals 1. Whether it's 2 to the power of 0 or 1,000 to the power of 0, it's always going to equal 1. And that gave me -2.
Oh.
That's why we want it to equal 0, because we know anything to 0 is 1. Okay, we do that because that should be easy math that we can do. Alright, so now, whenever I plug -4 in there, -4 plus 5 is going to be 1. 2 to the first power is what? 2. 2 minus 3 is -1. Then I would plug in -3, but that's going to give me an exponent of 4. Or sorry, an exponent of 2. 2 squared is, minus 3 is. And now I can more accurately graph where this is going to start going up. And even if you wanted to do 2 cubed to -8, that would be the next one, which would be 5, which would be there. But you really only need 3 points. Okay. So going to number 2. Anna, what is my horizontal asymptote here?
2.
Tyler, what's the domain? What's the range? -infinity to 2. An easy way to think about that is if the equation starts with negative, your range is going to start with -infinity. Okay. Let's go ahead and list the transformations, which Anna gave us the horizontal asymptote because it went up to. The negative, what does that do? reflects. And Zach, what's the last one do? Zach White, the -5 up there. Right 5. Okay. Zoe, what x value is going to make my exponent equal 0? So what -5 equals 0? 5. Remember, once you find that, the majority of the time, unless you have a b value, all you're doing is you're counting up by ones. Plug those in. Okay, I want to see if you can find those y values that go along with those. So if I plug 5 in for x, which gives me an exponent of 0, what y value does that give me? 1. You've got to be careful. Who said 3? Okay. So what you got to do, that only changes this to 1. So you still have -1 plus 2. Okay. So you got those. Then if I put 6 in, that gives me -4, to the first plus 2. And so that's going to give me what? -2. I plug 7 in, which is going to give me -14. Which I cannot graph. Okay, so let's graph the two that we have, and let's talk about that for a second. 5, 1, 6, -2. Okay, that is sufficient, but one thing that you can do is pick the x value that's going to give you an exponent of -1. Okay, so we'll add that on that list. Sometimes you'll need to find this. I would like for you to find 3. Sometimes whenever you find the y value that goes along with the exponent of 2, that's going to fall off this grid. So let's go through the process of plugging in 4 and dealing with a -1 exponent. So if I have -4 to the power of -1 plus 2, that negative exponent is going to do what? If I want to get rid of the negative exponent, what does it do to its base? Doesn't make it negative. It'll be negative because of the negative up front. But just that situation right there. That is the same as what? Do what? To get rid of the negative exponent, the base goes to the denominator, and that -1 is now +1, still on the 4. Okay, so now I end up with pretty much 2, or -1/4 plus 2, or 2 minus 1/4, which is going to give me 1.75. So you can see the path that is going to take. Okay. So let's go down to the bottom. Let's go through 3.
Are we going to be using calculators on a test or a quiz?
Yeah, you'll be able to in here. Alright, so looking at this, we'll just go through graphing it here. So, Hunter, what is my asymptote?
3.
Jeremy, what is my range?
Negative infinity to 3.
Why negative infinity first?
Because the A is negative.
Okay. So I've got my, or let's get into it. Josh, what x value is going to make my exponent 0?
Which Josh?
Josh Webb.
3.
So here's your exponent.
Oh, 4.
4 plus 4 is 8. Josh Starnes? Negative 4. Yeah. Okay. And remember, whenever you figure out, don't overthink the next two. Just count up by 1. If negative 4 gives me an exponent of 0, negative 3 is going to give me an exponent of 1. Negative 2 is going to give me an exponent of 2. If I do not have a b value. Okay. So I plug that in. I plug in negative 4, which that turns all of that to what? Well, I get an exponent of 0, but it changes it all to 1. So negative 3 times 1 plus 3 equals what? 0. Alright, I plug negative 3 in there. Okay, so I'm going to have negative 3 times 4 to the first plus 3. Negative 3 times 4 is what? Negative 12. Plus 3 is negative 9. So that means that if I do the squared one, is that probably going to fall off the graph? Yes. So instead of finding that one, I'm going to find the one that's going to give me, that has an exponent of negative 1. Okay, so let's go through this again. Negative 3 times 4 to the power of negative 1 plus 3. Okay, Jesse already told us that the negative exponent does what to its base? What did it do to it on number 2? It flipped it. So I've got negative 3 times 1/4 plus 3. That's going to give me negative 3/4 plus 3, which is what? What is 3 minus 0.75? 2.25. Okay, so there's 2.25. Now I've got negative 4, 0. Now I've got negative 3, negative 9. And now I can see, and you can see that whenever you have that a value, okay, it's going to drastically get off the graph. Alright, if you want to challenge yourself, again, especially if you are pre-cal bound, I want you to attempt that while I hand out the homework, and then once I'm done with that, I'll put that answer up there. You were working through number 4. Here's my best attempt at what would be the correct answer. And there's that graph for number 4.